Welcome to another video. In this video, we'll be looking at the tests for convergence. So we'll be focusing on two tests for convergence of a series rather. So first we'll talk about the geometric series. Now a geometric series is any series that can be written in the form. So we have the sum from n is equal to 1 to infinity of AR to the raised to the n minus 1. So it's r that is raised to n minus 1. And this will converge if r is greater than -1 but less than 1. Also, the geometric series can be written as the sum from n is equal to 0 to infinity of a, and then r is being raised to the m, so ar to the n. Now, just a note here, n is equal to 1 and we have r being raised to n minus 1, so n starts at 1 here, and when n starts at 0, then we have r simply being raised to n. Let's look at some examples. So example 1, determine if this guy here converges or diverges. Now the first thing that we're going to do is we're going to use our knowledge of indices, and we're going to break this into parts. So we have 5 to the negative n plus 2 times 4 to the n plus 1. So using our knowledge of indices, this is just 5 to the negative n times 5 squared, so 5 to the 2, times 4 to the n times 4 to the 1. Alright, I hope you guys remember your laws of indices. Now, we can simplify this as 100. Well, so we still have our summation sign here. So the sum from n equal 1 to infinity of 100, and we have 4 to the n divided by 5 to the n. Now, remember laws of indices, so 5 to the negative n, so we can write this in the denominator with a positive power, so 5 to the n, 5 squared, that's 25, times 4, that's 100, and simplifying, we just have 100 times 4 to the n divided by 5 to the n. Now, you might be tempted to just say, okay, yes, there it is, we're done. But remember, we want to write it in a particular form. Now here, n is equal to 1, so really we want to have n minus 1. So remember the form here. Yes, so when n is equal to 1, our r should be raised to n minus 1. So let's put it in that form. And once again, we rely on our knowledge of indices. So we want to have 4 to the n minus 1. So what we'll do is we multiply both numerator and the denominator by 4 to the negative 1. So applying our laws of indices, this would be 4 to the n, so the bases are the same, so we'll add the power, so this is just 4 to the n minus 1. Now 4 to the negative 1 here, this simply means we multiply by 4, so 4 to the negative 1, and that's in the denominator, so this will just be the same as multiplying by 4. So you might want to write it out. So remember, 4 to the negative 1 is 1 over 4, so you might want to write it out, and you'll realize that that is just the same as multiplying by 4. So now similarly, we want to have 5 to the n minus 1. So what do you think we multiply both the numerator and denominator by? If you guessed 5 to the negative 1, you would have been correct. So similarly, we can find that 5 to the n times 5 to the minus 1 is the same as 5 to the n minus 1 times 5 to the negative 1. Remember, this is just 1 over, this will just be 1 over 5, so this is the same as divided by 5, and that gives us 80. So now we have 80, the sum from n is equal to 1 to infinity of 80 times 4 to the n minus 1 divided by 5 to the n minus 1. And once again, using our knowledge of indices, we can write this simply as the sum from n is equal to 1 to infinity of 80 times 4 divided by 5, all raised to the n minus 1. So both of them have the same powers, so we can just write the power once, put it in bracket and write the power once. I hope you guys remember that law of indices. Now here clearly we can see that we have it in this form, and as such our r will be 4/5. And recall that this type of series will converge if r is greater than -1 but less than 1, and 4/5 will definitely fall in that region, and as such we say that this is convergent. We'll now look at another example. So we want to determine if this guy here converges or diverges. Now just a note, n starts at 0. So in this case, n starts at 0, and as such it means that all we need is to have the powers, or our r rather, being raised to n. So because it starts at 0, we just want the r to be raised to n, and not n minus 1 as in the previous case. So again, we apply our knowledge of indices. So this gives us -4 to the 3n. We can write that as -4 to the third power, so -4 cubed raised to the n. Remember, this is we'll just multiply these powers here based on the laws of indices. 5 to the n minus 1, this is just 5 to the n times 5 to the -1. Now this gives us 5 to the -1. That's just the same as multiplying by 5, because remember this is dividing by 1/5, which is the same as multiplying by 5. So that gives us this 5 here. -4 cubed, that gives us -64. So we have 5 times -64 to the n divided by 5 to the n. And once again, we can apply a similar rule or method that we did in the last time, where we say, all right, so this will just be, so we have -64 being raised to the n, we can look at it here, -64 being raised to the n, we have 5 being raised to the n, and as such we can say this can be written as -64 divided by 5, and all of this is raised to the n. So in this case, our r is -64 divided by 5, and clearly this is not in the region. So if we divide that by 5, then our result would be -12 point something, right? And that is definitely outside of the region for it to converge. So this series here is divergent. Now we'll talk briefly about the p-series. Now a p-series, so here we have the sum of 1 divided by n to the p, and this converges if and only if p is greater than 1. If p is less than or equal to 1, the series diverges. So for our first example, we want to determine if the sum from n equal 1 to infinity of n squared divided by 4 converges or diverges. Now the first thing that we're going to do is to simplify this series. So n squared divided by n to the 4th, this is simply 1 divided by n squared. And once again, this is just some laws of indices at play. Now clearly we can see that our p, so look at this. So 1 over n to the p, we have 1 over n squared. So clearly our p is 2. So we have a p series with p being equal to 2, and since p is equal to 2, remember it converges if and only if p is greater than 1. 2 is greater than 1, and therefore this series would be convergent. Example 2, we want to determine if, so we have 1 plus a half plus a third plus a quarter plus, and it continues. I think we can see the pattern. So next we'll have 1/5, then 1/6, then 1/7, 1/8, and so forth. So we need to determine if it converges or diverges. So that should be here, if it converges or diverges. So let's add that. If it converges, or I'll just say converges. Alright, So now we can rewrite our series using the summation sign. So we can rewrite this as the sum from n is equal to 1 to infinity of 1 divided by n. And you can check it, you can see, so when n is equal to 1, we'll have 1 divided by 1, which is just 1. Next we'll have n being equal to 2, so it's just 1 over 2, so that's a half. Then n will be 3, so that would give us a third, and so on. So clearly, once again, we have a p series, and in this case, what is the value of p? If you guessed that p is equal to 1, you would be correct. And based on what was said earlier, if p is equal to 1, what can we say about the series? The series is divergent, or we can say that it diverges. Example 3. So determine if 1 plus 1 over 8 plus 1 over 27 plus 1 over 64 plus it continues converges. Now, once again, we need to rewrite this using our summation sign. So we can write this as the sum from n is equal to 1 to infinity of 1 divided by n cubed. Now we can try it. So when n is equal to 1, we'll have 1 divided by 1 cubed. 1 cubed is just 1. 1 divided by 1 is 1. When n is equal to 2, we have 1 divided by 2 cubed. 2 cubed is 8. N is equal to 3, we have 1 divided by 3 cubed. That's 27, and so forth. So clearly, here, we have a p series where p is equal to 3. And since p is equal to 3, based on what was said, we know that this series is convergent. So that takes us to the end of our video. I hope you have learned something new today. Goodbye.